Astronomers have discovered a new planet, and in space terms, it's relatively close, just 4 light years away.
NASA's newest space observatory allows researchers to see further into the cosmos than ever before.
It began quietly, an anomaly slipping through columns of starlight, a faint pulse in the cosmos that hinted at something extraordinary. The James Webb Space Telescope, designed to give humanity new vision on the universe, focused its gaze on our nearest stellar neighbor, Alpha Centauri. What it found may alter what we think we know, not just about the next star over, but about the nature of planetary systems throughout our galaxy. Alpha Centauri. For many, the name conjures images of distant suns and unreachable worlds. For astronomers, it is far more, a scientific riddle, the closest possible stage for cosmic milestones, and perhaps a mirror to the secrets of our own solar system. For more than a century, scientists have analyzed its starlight for faint signs, subtle dips and wobbles in light's path that could signal hidden planets, clues orbiting around the 3 stars just over 4 light years away. For so long, there was nothing conclusive. Now that has changed. NASA's James Webb Space Telescope has provided the strongest evidence yet, a compelling indication of a massive, Jupiter-sized planet orbiting Alpha Centauri A, one of the 3 stars in this system. This is not a fleeting rumor or a speculative calculation. It is real evidence that challenges long-held assumptions. A world that eluded detection for generations, massive, gaseous, and perhaps even within the habitable zone that astronomers have long associated with the potential for life-supporting conditions. Yet, if this planet has been present all along, why did we miss it? How did it remain hidden until now? And more pressingly, what else in the cosmos escapes our gaze, waiting for the arrival of technology precise and sensitive enough to reveal the universe's true complexity? There is reason to wonder how many other giants, still undetected, still mysterious, are orbiting the stars nearest to us. Discovery at the edge of sunlight. For centuries, Alpha Centauri has drawn scientists and dreamers alike. It is both a beacon of hope, a target close enough to imagine visiting, and a confounding barrier separated from us by vast, untraversed darkness. Consisting of 3 stars, Alpha Centauri A and B, both similar to our Sun, and the faint red dwarf, Proxima Centauri, the system has long tempted astronomers as a possible home for planets like our own. Over the decades, ground-based telescopes peered through the shimmering distortions of the atmosphere. Space telescopes like Hubble joined the search, examining every flicker, every possible clue. Again and again, these attempts produced hints and false alarms. For decades, nothing solid emerged. The arrival of the James Webb Space Telescope transformed the search. Armed with instruments of unprecedented sensitivity, Webb was able to focus on Alpha Centauri with the ability to separate faint planetary signals from the overwhelming glare of its stars. Astronomers courted confirmation of old suspicions, perhaps the hint of a rocky world. Instead, what Webb uncovered was far from subtle. Within the golden light of Alpha Centauri A, Webb's near-infrared instruments detected an extended dip in the star's brightness, a shadow broader and more enduring than could be explained by dust or debris. The event had clear timing. Its shape was consistent. It repeated with the star's rhythm, suggesting something orbiting the star in a regular, multi-year trajectory. When data from Webb's other sensors were layered over this light curve, the picture sharpened further. In the gravitational dance, the minute tugs on Alpha Centauri A's position was the signature of something massive, not just a wandering asteroid or a transient cloud, but the recognizable effect of a planet as large as Jupiter. Furthermore, Webb detected a subtle hint of warmth from the planet's region, a possible indicator of the planet's atmosphere and its placement within the so-called habitable zone, the swath around a star where conditions may be suitable for liquid water. The planet appears to be a gas giant, echoing the ones that reign in the outer solar regions of our own solar system, but unusually situated in a location where, on smaller planets, the temperature might allow water to exist. Here was the first clear glimpse. A planet, not a faint rocky body, but something huge and hidden, revealed only thanks to Webb's unprecedented vision. What its presence means for understanding Alpha Centauri's structure, and potentially for other planetary systems, is immense. Why are these hidden giants so important? If you're intrigued and want to keep exploring discoveries like this, be sure to subscribe. Now, let's move on. The silent architects of solar systems. In our solar system, the giant planets, Jupiter, Saturn, Uranus, Neptune, govern the architecture of planetary orbits and the fate of smaller bodies. Jupiter's gravity, especially, has played a major role, helping to shield Earth from repeated bombardment by comets and asteroids, while simultaneously influencing their paths and distribution. Theorists have long argued that gas giants play far greater roles than mere planetary companions. They shape planetary formation, act as both protectors and threats, and direct the flows of material that may become moons, worlds, or even the seeds of life. These giants can clear out debris, perturb orbits, and define the possible arrangements and stability of other planets. To find a giant planet orbiting Alpha Centauri A, within the habitable zone no less, changes possibilities for the system's evolutionary history. Webb's evidence suggests the presence of a gravitational force comparable to Jupiter's, which could have profound implications for the existence and survivability of smaller, potentially rocky planets or moons in this neighboring system. The ramifications are vast. If Alpha Centauri A possesses a gas giant in its habitable zone, the likelihood of rocky, Earth-sized planets forming and enduring changes in crucial ways. Such a giant could act as a guardian, protecting fledgling Earths from heavy bombardment. Alternatively, it could serve as a source of instability, flinging smaller bodies inward or outward, complicating the development of life-sustaining conditions. Crucially, if a planet of this size and position remained hidden for so long in the closest star system to ours, how many other systems might hide similar giants? Are these planets common, the rule rather than the exception? Have we underestimated the role that unseen, massive neighbors play in planetary evolution throughout the galaxy? The structure and stability of planets in a system as complex as Alpha Centauri, a dance of 3 stars, only deepen the mystery. How does such stability persist amid so much gravitational interaction? Shadow games, the search for evidence. Planet hunting around Alpha Centauri has always been a game defined by shadows and subtlety. Tiny dips in brightness, minuscule wobbles in a star's motion, analyzed against a background of cosmic noise. The breakthrough came when Webb identified not only a symmetric light curve, but also a pattern of regularity, shallow, precise dips in starlight that corresponded to what would be expected if a large planet were transiting its star. False positives, generated by stellar variability, flares, or dust, are common. However, Webb's sensitivity and variety of independent measurements made the case stronger. Beyond the transit itself, astronomers looked for the chemical fingerprints in the starlight that might denote a planetary atmosphere: hydrogen, methane, perhaps even water vapor. Webb's infrared observations detected an excess emission, suggestive of heat, radiating from a planetary atmosphere. The thermal signature expected from a gas giant's upper layers, not a cold, inert rock. Simultaneously, precision instruments measured the slight gravitational wobble in Alpha Centauri A caused by the orbiting planet, a motion analogous to the Sun's response to the mass of Jupiter. Taken together, these separate lines of evidence, repeated starlight dips, thermal emission in the right locations, corresponding gravitational shifts, combine to produce the strongest case yet for a giant planet orbiting our closest solar neighbor. Importantly, the planet's orbit appears to be unusually stable for a world in a triple star system. Rather than being flung between the gravitational pulls of A, B, and Proxima Centauri, the data show the planet follows a predictable path, more sanctuary than crossfire. This raises questions about planetary formation and survival in environments unlike our own. How could such regularity persist where one might expect only chaos? The habitable zone, a stage set for wonders. To astronomers, the habitable zone is the region around a star where a planet's temperature could support liquid water at the surface, an essential ingredient for life as we know it. Alpha Centauri A shares many traits with our Sun, and its habitable zone is similarly a focus of enormous interest. Now, Webb's observations suggest the gas giant resides squarely in this region. But what does the presence of a gas giant in such an orbit mean for the prospects of life or the system's architecture? On its own, a gas giant in the habitable zone is unlikely to host life. But, as our solar system's Jupiter and Saturn demonstrate, giant planets often have extensive families of moons. Some of these moons, like Europa and Enceladus, are considered prime locations for potential life, owing to their subsurface oceans and the warmth generated by tidal interactions with their parent planets. This raises compelling possibilities for Alpha Centauri A's newly detected planet. If it too has moons, and if conditions align just right, such moons could exist in environments suitable for life. Tidal heating could maintain internal warmth, and protection from the planet's magnetosphere could help shelter them from damaging radiation. However, giant planets also pose threats. Their gravitational grip can limit the stable orbits allowable for other planets or moons nearby. Eclipses might periodically plunge their moons into darkness, presenting challenges for surface habitability or climate stability. Furthermore, the gravitational pulls of the other two stars in the Alpha Centauri system add additional complexity to the system's long-term dynamism, even if current data suggest a stable orbit for the gas giant. The matter of time is essential. For life to emerge and evolve, environments need to be stable over very long periods. The regularity of the planet's motion, as indicated by Webb, suggests that stability can arise even amid the turbulence of a multi-star system, at least in some configurations. The cloak of proximity, why we didn't see it. 4 light-years, a negligible gap, in cosmic perspective, separates us from Alpha Centauri. So how could a planet as massive as Jupiter go unseen in such a well-studied region? Several challenges exist. First is the brightness. Alpha Centauri A shines brilliantly, and distinguishing the feeble glow from a planet is a task akin to spotting a candle near a bonfire. Next, the proximity of Alpha Centauri's 3 stars complicates matters. Their shifting orbits and overlapping light fields generate a wash of brightness and gravitational influences that can obscure or mimic planetary signals. Most prior searches, especially from ground-based observatories, were hindered by atmospheric effects and the challenges of isolating faint planetary signatures from the combined glare of multiple stars. Previous space telescopes lacked the required sensitivity, particularly in the infrared spectrum, where planets emit most strongly. The James Webb Space Telescope's instruments, orbiting well beyond Earth's atmosphere, offer much higher sensitivity and precision. Webb can discriminate not just between signals by position, but also by energy and phase. This allowed astronomers to isolate the faint heat signature of the planet, even amidst the overwhelming starlight, and to capture the precise dimming and wobbles attributable to the planet's transit and gravity. Still, the fact that this planet eluded detection for so long, so nearby, is a humbling reminder of both technological limitations and the enduring subtlety of nature's workings. Even with intense scrutiny, the cosmos can hold its secrets, sometimes in the very places we look most often. The giants among us. Implications for planetary science. Webb's findings are more than the discovery of another exoplanet. They offer a chance to reflect anew on planetary formation and the range of possible outcomes. Jupiter's massive presence has shaped everything about our solar system, from the arrangement of the planets to the population of comets and asteroids to the emergence of stable conditions for life on Earth. A similar planet orbiting close by in Alpha Centauri A's habitable zone raises profound questions about what normal planetary systems look like. Are neighbors like ours unusual or common? Do gas giants in habitable zones more often prevent the emergence of terrestrial life, or do they facilitate it by acting as cosmic shields? Each possibility reframes our understanding of planetary evolution. If such gas giants are common in habitable zones, the search for life may need to focus more on moons, not just Earth-like planets. Alternatively, if they act as disruptors, perhaps we occupy a rare and precious niche in the galaxy. Further, the stability of the giant planet's orbit, despite the complex gravitational tug-of-war present in a triple-star system, challenges our models for planetary formation and survival. This system's configuration may reveal mechanisms that allow planets, even in complex environments, to maintain steady paths for billions of years. Astronomers are now scrutinizing the broader sample of exoplanets with renewed focus. How many may have gone undetected, even in the closest systems? How do orbital resonances or migration histories factor in? And most importantly, could any such worlds or their moons be potential sites for life? A new era of exoplanet discovery. The catalogue of exoplanets has grown dramatically in the past few decades, yet the search for planets around Alpha Centauri was particularly stymied by its brightness and complexity. Webb's discovery signifies a leap forward, not only in technique, but in the very possibility of finding planets in the most challenging and luminous regions nearby. With Webb's data, telescopes worldwide will refocus their gaze on Alpha Centauri, searching not just for repeated confirmations, but for every possible planetary signature, from larger giants to smaller rocky candidates. Webb's unprecedented precision opens up a new window to probe the system for additional bodies, perhaps ones more similar in size and composition to Earth. In light of these results, scientists are re-examining older observations, hunting for echoes of past events or clues that may now be more comprehensible. Even Proxima Centauri, already known to have a small, temperate exoplanet, may now be viewed in a new context, as researchers ask whether additional companions could lurk there too. With each technological advance and improved analysis, our view of the cosmos becomes sharper and more complex. Planets passed over today may become the discoveries of tomorrow, and the line separating known from unknown continues to shift. Webb marks a profound turning point in humanity's engagement with the universe. No longer do we rely solely on indirect hints. The direct signs, and perhaps eventually detailed views, of planets orbiting our nearest neighbors and brightest stars become increasingly possible. The path forward, resolving the mystery. This newly uncovered planet is more than just a point of light caught by new technology. It is an invitation to question, to imagine, and, most importantly, to pursue deeper answers. Astronomers are now planning additional observations using Webb and other telescopes, aiming to refine measurements of the planet's mass, orbit, and atmospheric composition. They hope to confirm the precise boundaries of the habitable zone, evaluate the likelihood and nature of any moons, and understand how this planet maintained a stable path amidst the shifting forces of three suns. International space agencies are also discussing how this discovery could accelerate efforts to probe Alpha Centauri more directly. The detection of a giant planet with the potential for moons invigorates the long-standing dreams of interstellar exploration, whether by robotic probes, light sails, or future missions yet to be devised. Scientists emphasize that while these are the strongest findings yet, far surpassing earlier ambiguous signals, scientific confirmation will require confirmatory measurements and years of data. Nonetheless, the evidence from Webb marks a new chapter, transforming Alpha Centauri from an abstract possibility into a system with measured structure and known, active planetary dynamics. What to expect next? With each pass, Webb and other instruments will gather deeper readings, characterizing the planet's atmosphere, searching for signs of chemical processes, and modeling how its presence affects the potential for other planets or moons to exist close by. There is now heightened interest in monitoring Alpha Centauri A for natural radio emissions and subtle changes that might hint at further planetary bodies or intriguing chemistry. Sophisticated models will explore how the gravitational relationships among the three stars, the giant planet, and possible moons or other planets might play out over time. Each step forward brings us closer to understanding not just Alpha Centauri, but the broader possibilities for planetary system evolution and habitability throughout our galaxy. Looking outward and inward, the Webb Telescope's evidence of a giant planet orbiting Alpha Centauri A stands as a milestone, both for technical achievement and for what it reveals about the universe. 4 light-years is now a bridge, spanned by the tools of science and the collective curiosity of humanity. There is a sobering lesson in this discovery. If such a dominant world, in so close a system, remained hidden for so long, how much more remains to be found? Each new observation reveals as much about our limitations as about the cosmos. Alpha Centauri, for so long a focus of speculation and dreams, now emerges as a system with measurable structure and apparent planetary complexity. This single breakthrough opens the possibility that our nearest neighbors may not be barren, but rich with potential, whether for future exploration, the search for life, or fundamental understanding of how planets and solar systems arise and evolve. With each discovery, our place in the cosmos grows, at once less isolated and more intricate. Conclusion: the new frontier. the discovery of a massive planet circling Alpha Centauri. Reframes our solar neighborhood. No longer can we think of other star systems, especially those so close, in simple terms. The evidence is mounting. Complex worlds abound, sometimes shrouded from view not by distance, but by the very brightness that makes them so visible to the naked eye. Webb's observations urge us to search more deeply, reconsider old data, and challenge our assumptions about the rarity and role of planetary giants. They remind us that discovery is not the end, but the beginning, raising new questions and inviting future explorations. As the James Webb Space Telescope continues its observations and new missions rise to meet the challenge, the secrets of our nearest stellar neighbor move from the realm of speculation to that of scientific fact. Alpha Centauri is no longer an abstraction. It is a destination, a dynamic system, and a symbol of mysteries that even next door are waiting to be revealed. The story of discovery has entered a new era, marked by humility, ingenuity, and the ever-present drive to know more. The hidden world, long invisible, now beckons as both challenge and promise. We move forward, inspired by the realization that the universe's wonders are closer than we dared imagine, and knowing that with each new discovery, our perspective and place within the cosmos may be forever changed.